coding gains with polar baseband PPSK baseband. Coding gain dB at 10 power minus 5 PER. Coding gain dB at 10 power minus 8 BER. Data rate capability. Coding technique used. Ideal coding. Turbo code, yes. Ideal coding 7.2 here in 10 power 5 minus 5 here. Here 13.6 in 10 power 8. Data rate capability. Turbo code concatenated. Turbo code 8.8. Concatenated 6.5 to 7.5, 8.5 to 9.5 here in 10 power minus 8, 10 power minus 5. Yes, moderate. Read concatenated read Solomon and convolution Viterbi decoding. This actually this one here. Ideal coding, turbo code, ideal coding, this is turbo code, this is concatenated code, this is read Solomon and convolution terrorism. Convolution Viterbi decoding. This one 6.0 to 7.6 to 7, 8 to 9, moderate. Conversion with sequential decoding, soft decisions. 5 to 6, 6.5 to 7.5, moderate. Block codes, soft decision 4.5 to 5.5, 6.5 to 7.5, very high. Concatenated read Solomon and short block 4.0 to 5.5, 5 to 6.5, high. Conventional with Viterbi decoding 4 to 5, 6 to 7, high. Conventional with sequential decoding, hard decisions 3 to 4, 4.5 to 5.5, high. Block codes, hard decisions 2.0, 4, this one. Block code with threshold holding 2.5 to 4, here 1.5 to 3, very high. 2 to 4, 3.5 to 5, high. This one. And this, correct, no? Two different encoders are used in series at the transmitter. See figure 1.4, and the corresponding decoders are used at the receiver. And second one, signal and spectra. Here basic signal properties, DC, RMS, dBm, power, Fourier transform spectra, linear systems and linear distortion, band limited signal and sampling, discrete Fourier transform, DFT, bandwidth signals, properties of signals and noise. Here physical and mathematical waveforms. Physical and mathematical waveforms. This is the physical waveforms, physical waveform. Waveform decays to 0 before t equal to minus infinity. Omega t or omega of t. Here t 3 2t 3t 4t 5t 6t 7t t. This is physical waveform. Waveform decays to 0 before t equal to plus infinity. Waveforms decays to 0 before t equal to plus infinity. Omega t is math model form. Waveform extends t equal to minus infinity. Waveform extends to plus infinity. T, 2t, 3t, 4t, 5t, 6t, 7t, t. Time average operator. The time average operator is given by limit t to infinity 1 by t minus t by 2 integral over of minus t by 2 to t by 2 dot product t dt. Waveform Wt is periodic with the period t naught. If omega t equal to omega of t plus t naught for all t. T naught is a small positive number that satisfies the relationship. If the wave theorem, if the waveform involved periodic time average operator can be reduced 1 by t naught minus t naught 2 by 2 t naught by 2 plus a here plus a dot product dt, where t naught is the period of the waveform and a is the arbitrary real constant which may be taken to be 0. Dc value Wdc equal to limit t to infinity 1 by t minus t by 2 or integral over of minus t by 2 to t by 2 omega of t dt. The DC direct current value of a waveform, the omega t is given by its time average omega t power p of t equal to v of t I of t. Instantaneous power, the average power p equal to p of t equal to v of t I of t. Polarity converter used for voltage and current. This is the circuit. Here v of t input I of t. Polarity conversion used for voltage and current. Evaluation of power. Voltage. Sinusoidal wave 0 1 by 2 t naught t. Here Vrms t naught v of t v. Okay. Current sinusoidal waveform. This is in between here Irms current I. Here in between this Vrms. Okay. T. This is power, instantaneous power. VIE 1 by 2 t naught 1 by 2 VI t the time power t in y axis x axis t. Steady state wave shape for example 2.2. Steady state wave shapes. RMS value and normalized power. The root mean square value of omega t is Wrms equal to root of omega square of t. If a load is resistive, that is with the unity power factor, the average power is P equal to V square T divided by R, I square equal to I square T and R, V square RMS divided by R. Here I square RMS R equal to VRMS IRMS, where R is the value of the residual load. The average normalized power is P equal to omega square T equal to limit T to infinity 1 by T integral over minus T by 2 to T by 2 omega square T dt. Omega T represents the real voltage current waveform. Error and power waveforms. Omega T is the power waveform if and only if the normalized average power P, if it is finite non-zero, that is 0 to infinity. 0 is less than P, P is less than infinity. Total normalized energy is E equal to limit of T tends to infinity minus T by 2 to integral over minus T by 2 to T by 2 omega square T dt. Omega T is a waveform if and only if the total normalized energy is finite and non-zero, 0 to infinity, that is 0 is less than E and less than infinity. Decibel. The decibel is a base 10 logarithmic measure of power ratio. For example, the ratio of the power level at the output circuit compared with the input of the specified by the decibel gain instead of the actual ratio. The decibel gain of a circuit is dB equal to 10 log of average power output average power in equal to 10 log of P out to P in. dB equal to 20 log of VRMS out divided by VRMS in plus 10 log RI R in divided by R load, or dB equal to 20 log IRMS out divided by IRMS plus 10 log of R load divided by RI. Then what is the difference? 20 log VRMS out, here voltage, here current, here same resistance. Then P out divided by P in equal to 10 power dB divided 10. The decibel signal to noise ratio is S divided by N dB, 10 log P signal divided by P noise, 10 log of S square of T, N square of T divided by N square of T. So S signal to noise ratio in dB equal to 20 log of VRMS signal divided by VRMS noise. Definition: the decibel power level with respect to 1 MW is dBm equal to 10 log into actual power level watts divided by 10 power minus 3, 30 plus log 10 log actual power level watts. dBm. Laboratory RF signal generators are usually calculated in terms of dBm. dBm equal to 20 log of VRMS divided by 10 power minus 3. Zero dBm V corresponds to minus 48.75 dBm. Phasors. Sinusoidal test signal occur upon electrical engineering problems, that is shorthand notation, phasor notation. A complex number C is said to be a phasor if it is used to represent a sinusoidal waveform. Omega of t equal to mod of C cos of omega naught t plus angle C equal to RE of CE j omega naught t. Fourier transform and spectra. Definition: the Fourier transform of a waveform W omega t is a W of f equal to f of W of t equal to integral over minus infinity plus infinity omega t omega of t into e power minus j 2 pi ft dt, where f